right, today we're covering chapter 2, lesson 4, writing linear equations. So what we're going to cover in this lesson is writing an equation of a line given the slope and the point of a line, writing an equation of a line parallel or perpendicular to a given line. So some vocabulary is slope-intercept form and point-slope form. So kind of one of the big questions here is how do linear equations apply to business? Here's something we can examine. Um, so when a company manufactures a product, they must consider two types of costs. There is a fixed cost, which they must pay no matter how many of a product they produce, and there is variable costs, which depends on how many of the product they produce. So one is fixed, right? There's no getting around it, and the other one is a cost based off how much they produce. So in some cases, the total cost can be found by using a linear equation, such as y equals 5400 plus 1.37x. So 5400 would be a fixed cost, and 1.37 would be the cost per unit being produced. So a couple of the different equations we're going to be looking at is first is slope-intercept form. And if we were to consider this line here with point C and point A, where this has an x and y coordinate and this has a coordinate of 0b, right? If we were to examine this and we'd use the slope formula to find the slope, right? We know that slope equals y2 minus y1 over x2 minus x1, right? The normal slope formula. So if I used my y coordinates, y and b, and my x coordinates, x and 0, and substituted those in, and I would find that my slope equals y minus b over x. And so if I had this equation here, right, I have lots of variables. But if I were to take this equation and solve it for y, you might see something interesting, right? If I were to take this and multiply both sides by x, it would give me mx equals y minus b, right? And then if I added b to both sides, it would give me mx plus b equals y. Now this might start to look familiar. And if I use the symmetric property of equality, right, I can just switch the two sides of the equation. This would tell me that y equals mx plus b. And this should look familiar, right? This should be known as slope-intercept form. Okay, and slope-intercept form is probably the most common and most widely used form of linear equations. So slope-intercept form is an equation of a line where y equals mx plus b, where m is the slope, right? And b is the y-intercept, and y and x are just variables representing your x and y coordinate that satisfies that line, right? So slope and y-intercept are big things to take away here, because with that information, we can always plot our y-intercept and then count our slope to make our line. So if you're given the slope and the y-intercept of a line, you can find an equation of a line by substituting those values in for m and b. And so, for example, if someone said you had a slope of -3 and a y-intercept of 4, we could substitute them into our equation here for m and b, right? And it would give us y equals -3x plus 4, right? In standard form, it would look like this, right? It would be 3x plus y equals 4. This is slope-intercept form. This is standard form. Again, connecting to some of the sections that we covered already. You can also use slope-intercept form to find an equation of a line if you know the slope and the coordinates of any point of a line. So just to kind of keep in mind here, the equation of a vertical line typically can't be written in slope-intercept form because the slope is undefined. So you can't substitute anything in for m there. And if you remember, the equation for a vertical line is just x equals a constant, right? Some number. So in example 1 here, they want you to write an equation given a slope and a point. So here we're going to write an equation in slope-intercept form with a slope of -3/2 and passes through the point -4, 1. So first we're going to substitute m, x, and y because this is our m, our slope, and this is our x coordinate and y coordinate. So we'll substitute them into this equation, right? Our y value is 1, our slope was -3/2, and our x value is -4. So now we're going to go ahead and simplify it, right? Multiply this out, gives me 6. And then I subtract 6 from both sides, and I get b equals -5. So now I know my y-intercept. So now that allows me to use my y-intercept of -5 and my slope of -3/2 to write my slope-intercept form of the equation. This is what the line would look like if we were to graph it, right? It goes through the point -4, 1, down 3/2. And again, it also matches this one with a y-intercept of -5, and again, the slope of down 3/2. Point slope form of a linear equation is also something we'll use. If you're given the coordinates of 2 points of a line, you can use point slope form to find an equation of the line that passes through them, right? So this is the point slope form, right? Y minus y1 equals m times x minus x1. And y1 and x1 are the x and y coordinates for the point that you're using. M still represents the slope, and the x and y without the subscript of 1 is just the x and y variable. So again, this is our point slope form right here. And these are the places where we make our substitutions, right? A y coordinate, an x coordinate, and a slope. So let's see what that looks like. If I were going to write an equation for 2 given points, here are my 2 points. I'm going to go ahead and find my slope. Again, using the slope formula, substitute your y coordinates and your x coordinates. So go ahead and simplify, and that would give you 1 over -3 or -1/3. And so now that I have my slope, I'm going to go ahead and use that point slope form, right? With my slope and my x and y coordinate, substitute in my values, and then go ahead and simplify. This would give me -1/3 times x, -1/3 times -1. So when you simplify this all, now we're going to solve for y. So I'm going to go ahead and add 4 to both sides, and I get y equals -1/3 x plus 11/3. So when changes in real-world situations occur at a linear rate, a linear equation can be used as a model for describing the situation. So here's an example. A salesperson, Eric Fu, is paid a daily salary plus commission. When his sales are $1,000, he makes $100. When his sales are $1,400, he makes $120. So we're going to write a linear equation to model the situation. We're going to also find out what his daily salary is and commission rate is. And then we're going to find out how much he would make if his sales were $2,000. All right, so let's go ahead and look at part A. So it says, write a linear equation to model this situation. So we're going to let x be the sales, his sales, and we're going to let y be the amount of money that he makes. And we're going to use the points 1,100, right? $1,000 is what he, are his sales, and $100 would be what he makes. And then again here, $1,400 are his sales, and $120 is what he makes. So these are our 2 points that we're going to use. So we'll use our slope formula, right? So we'll put in our difference in y values over our difference in x values, and we find that our slope will simplify down to 0.05. So now we're going to use that slope and either one of the points, it doesn't matter which one you use, to write an equation. So again, here's our point slope form equation. I'm going to use my slope of 0.05, and I'll use the point 1,100, right? So 1,000 for my x value, 100 for my y value. It's just this point right here. You could have used this point. It'll still get you to the same final answer. So here, I'm going to go ahead and start simplifying, right? Use the distributive property, and then go ahead and add 100 to each side, and you get the equation. Y equals 0.05x plus 50. So now you can see that we've simplified it down into slope-intercept form. So we're going to go ahead and utilize that slope-intercept form of the equation. We can make a graph that'll look something like this, right? Your x-axis, your y-axis, y-intercept of 50 with the correct slope, okay? And then part B says, what are Mr. Fu's daily salary and commission rate? So we're going to utilize our equation to answer that, right? So the y-intercept of the line is 50, right? So 50 is his daily salary. Basically, he's going to make $50 a day, regardless of how much he sells, right? And then his commission rate is our slope, right? That's how much he makes depending on how much he sells, right? So since our slope is 0.05, we would want to convert that into a percentage, right? Because typically commissions are in percentages. So 0.05 is actually just 5%, right? You can move the decimal place 2 spots to the right or multiply it by 100, and that gives you your percentage of 5. So let's go ahead and answer part C now. So it says, how much would he make in a day if Mr. Fu's sales were $2,000? Now, on our graph, it would fall somewhere over here, and we can't really see what that is. So we're going to utilize our equation to find this answer, right? So if his sales are $2,000, we can put 2,000 in for x into our equation, right? So if we put $2,000 in here, right, we're going to go ahead and use and simplify this equation. 0.05 times 2,000 gives us 100, and 100 plus 50 gives us 150. So therefore, Mr. Fu would make $150 if he sells $2,000 worth of stuff. So between his daily salary and his commission, he would make $150. So parallel and perpendicular lines. The slope-intercept and point-slope forms can be used to find equations of lines that are both parallel or perpendicular to given lines. So here's an example. So write an equation of a line that passes through the point -4, 3, and is perpendicular to whose equation is to a line whose equation is y equals -4x minus 1. So remembering perpendicular lines have opposite and reciprocal slopes is going to be really helpful in this problem. So the slope of this line is -4, right? So our line is going to have a slope of positive 1/4, right? Opposite and reciprocal. So opposite of a negative is a positive, and the reciprocal of 4 is 1/4, right? Because this is like 4 over 1, and that's going to be the reciprocal is going to be 1/4. So our slope that we're going to have for our perpendicular line is going to be positive 1/4. So using the point slope form of the equation and the ordered pair -4, 3, we're going to be able to write this. So let's go ahead and use our point slope form here. And so again, my slope that I'm going to use is this perpendicular slope, 1/4. And then my x and y coordinate is going to be -4, 3. So I'm going to put those into my equation. And then I'm going to go ahead and simplify this, right? I'm going to go ahead and simplify this, right? 1/4 times x is 1/4 x. This actually, these two negatives become +4. So 1/4 times 4 is 1. And then I'm going to go ahead and add 3 to both sides, and I get y equals 1/4 x plus 4. So that would be the equation to the line in slope-intercept form. Y equals 1/4 x plus 4. So it's got a slope of 1/4 and a y-intercept of 4. So my equation would look something like this. Here's the equation to the original line, right? And my perpendicular line is this one right here, right? It's got a y-intercept of positive 4 with a slope of 1/4, right? And if you notice, these two lines are exactly perpendicular to each other. Right? Thank you guys for watching. Let me know if you guys have any questions.